Technical problems. You cannot start a conference without technical problems. That's normal. That's how it works. Okay, cool. So I'll be speaking today about serverless deployment, serverless way how to run stuff. I'll show you what I'll be using. So now let me turn this on. Wait. Come on. Okay, so this is how I look like. My name is Viktor. Come on. Okay, today is not the day. Okay, excellent. So I work for a company called CloudBees. We're a company behind, you're probably most familiar with Jenkins. We have some other products. This is not a marketing campaign, so I'm not going to speak about them. I work a lot with Google. I'm one of the Google developers experts, and I'm one of the Docker captains. We'll see how long the company will survive, but so far it's still there. I have blog, I have books, I have more books, I have podcasts, I have Twitter. Now you know everything about me, and we can continue and do the cool stuff. So what I did before I started this presentation, I created quickly a Kubernetes cluster, in this case on Google, but it works the same everywhere. And I installed a couple of things. I'm going to show you those things later, but let's speak first about serverless. So we've been working for a year and a half, more or less, redesigning completely Jenkins. Now it's called Jenkins X. It has nothing to do with Jenkins, completely new stuff. And one of the most important things we had when we were designing the solution is that it needs to be serverless. And it needs to be serverless for a very simple reason, because the way how CI/CD tools work is that they have very varied workload, right? At one moment you have 1,000 builds and tests running somewhere, and then next moment only one, and then moment after that 10,000. So it's going up and down all the time. And if you would use traditional approach where things are running all the time, that is basically a disaster, because it uses too much power, too much CPU, too much memory, too much whatever, right? So what we were wondering is, can we apply the same thing what we are doing, and not only us, quite a few other companies, to normal applications? Like, can you run your applications in serverless? And the obvious answer is yes. You already heard, this is not the first time somebody's talking about serverless, but I'm going to show you a way how you can run serverless that you might not be familiar with. Let's go back in time a bit. So a long time ago, what we were doing, let's say 10 years ago, 15 years ago, we were deploying our applications on servers. We were putting them there, and then we would wait for a week until it runs there, and it was a nightmare, right? And then came quite a few changes. Why is this clicker not working? We got cloud computing, right? The complete things, everybody's on cloud right now? No? On-prem? Oh, my sympathies. My condolences. Okay, that's okay. You'll get there. We got cloud computing. And when I say cloud computing, it doesn't necessarily have to be Google or AWS or Azure or wherever you're running. You can run cloud computing on-prem. That's all okay. It can be done. I haven't seen a successful one running on-prem, but they say it can be done, so you can try. That's okay. And what is it? Like 5, 6, 7 years ago, we got containers. Right? And that was a huge change in how we do stuff. And when I say we got containers, what I really want to say is that 5, 6 years ago, containers became popular with Docker. We had containers like for 15 years. It's just that it was too complicated to use. It was too low level. But now everything is running in containers. And then we realized after a while that containers is not enough, because containers are still relatively low level. It does not really give you the flexibility you need. So we got schedulers, and we had Nomad and Swarm and what else? Mesos, rest in peace. Kubernetes, right? Everybody's using Kubernetes today. Kubernetes? You're grim in this country. What's going on? Okay. And now the new thing and the new wave of the changes is that we are now moving towards serverless. When I say serverless, I don't mean that everybody will run everything as a serverless mode. That's impossible, that's silly, that will never happen. But serverless are coming, they are already a thing, and you will be doing that. Now, serverless has quite a few problems today. And the first and the biggest problem right now is that you're going to be locked into a certain vendor, right? You're going to choose Lambda in AWS or Azure Functions or whatever they call it in Google, and then you're going to spend 3 years developing stuff there, and then you're going to realize that you will never be able to get away from whichever vendor you chose, simply because it's designed to lock you in. There is no real standard. There is no real guidance that can be used by all those vendors to create something that can run anywhere, right? You're very, very locked in. I mean, there is a standard for serverless, but nobody really uses it because that defies quite a few other problems. Now, you can run it, if you don't want to run it in cloud, you can run it on-prem, but then that's silly as well, because what's the point of serverless if you need to spend tremendous amount of time managing the servers where serverless is running? That, again, defies one of the main principles of serverless. I don't really care where it's running. I don't really care about the underlying hardware. All I want is to have this piece of code running somewhere, right? That's the beauty of serverless. And another problem of serverless, and I think that to me personally that's the biggest one, is that if you go with the cloud vendors, you need to have a function as a service, right? Serverless is a function, meaning that, I don't know, 10, 100, maybe a few hundred lines of code, and that's your application. Now, that's great, that's amazing. When you see those demos, they always show you how they use serverless to convert an image from raw format to HPG or something like that. It's always a silly, silly example. And that's because simply most of the loads cannot run as functions, right? If you take a serious company with hundreds of thousands of lines of code, take a challenge, try to convert all that in serverless, come back to me 10 years later and tell me how it works, right? It will not work, because functions are good for some things, but don't fool yourself that you will transform everything you have into 50 lines of functions one by one, that you're going to have tens of thousands of functions. That's not going to work. So where we are going right now, I mean, where I believe that we are going is that we are going to be running things in Kubernetes. And I don't think that Kubernetes is there, everybody is using it, or everybody is planning to use it. Those of you not using Kubernetes, most likely somebody in your company is exploring it right now. If you're not using it today, you will be using next year or year after that, but everything is going to Kubernetes because it's awesome. So everybody is using Kubernetes, or everybody is planning to use Kubernetes. So we have some kind of a format, some kind of a standard, some kind of API that everybody is using, no matter whether you're running on Azure or AWS or Google or on-prem, does not matter. You have a unique API used by everybody. That's awesome. It is a standard. It is not owned by any single company. It is open source, even though big companies are contributing and all those things. So it is a standard, and it does not lock you in. Now, knowing all that about Kubernetes, wouldn't it be awesome if actually we could, given that you already have a Kubernetes cluster, if you don't pretend that you have, because you will. So you have a Kubernetes cluster, then you're already managing it, you're already spending time making sure that it's running and all those things, whatever you need to do with it. So why not use that for your serverless loads as well? And that's where a project called Knative, sorry, not Canico, enters in. Anybody familiar? Two of you are familiar with Kubernetes, so it can be maximum two of you knowing Canico. So, sorry, not Canico, why am I saying Canico? Knative. So Knative is a project, it's open source, it started by Google, now we have Red Hat contributing to it, I think Microsoft, I mean, basically everybody is contributing to it, everybody is hopefully planning to move their serverless loads onto that. I think it started like 2 years ago, something like that. So, why is it cool? First of all, because it's Kubernetes, because it's standard and all those things. But what makes it really cool is that anything that can run in a container can run as serverless. Unlike serverless functions, Lambda, etc., that needs to be functions, this is basically anything that can run in a Kubernetes. Anything that can run in container can be can run in serverless. And I'm going to show you that in a few seconds. Now, there are, of course, few things, like your application should be relatively fast. So if you have web logic, please don't put it in container at all. And if you put it in a container, don't make it serverless. Simply, it's not designed. It's like 1999 or something like that. But if it's a decently fast application, I don't know, what's favorite here? Java, I guess, Spring Boot, something like that, right? Then it's a good candidate. And it's a good candidate if it's stateless. And all those things that I'm saying here, it should be fast, it should be stateless, those are the things you should be doing anyway, right? It's not the rules for serverless, it's the rules that you should be doing all those things in any case. And the best use case that I found so far for serverless is preview environments. I'm going to show you preview environments in like 10 minutes, something like that. But so far, basically the idea behind preview environments is that traditionally, you have a process, automated process, that whenever you push something to some Git repository, it is ultimately some moment, some point deployed to staging environment, and then pre-production, integration, production, and all those environments, right? Now, obviously, that is not enough. Obviously, we are all moving towards pull requests. You're making a pull request, and what do you need when you make a pull request? You need to review the code, you need to do this and that, and you need that pull request to be deployed to an environment, right? Because otherwise, how the heck are you going to review a pull request if you don't have an environment where that pull request is running? It's kind of ridiculous. It cannot be done without it, even though most people are not doing it. And the problem with pull request environments, we call it preview environments, is that at any given moment, you might have 10, 100,000 pull requests opening within your company. And all those environments are using a lot of CPU, a lot of memory, a lot of something. And most of the time, you're not actually really reviewing pull requests. You're just waiting until something happens. And that's most likely the best candidate for serverless, because you have a huge amount of wasted CPU and memory that is sitting there waiting for you to eventually sometime, some moment in the future review it. Okay, so I don't like to talk for long, so what we're going to do next is that I'm going to show you how it all works. Now, the architecture is relatively simple. You have a load balancer, external load balancer, because you need to have an external load balancer that will provide a stable IP, something your DNS can know to go to, and that load balancer is going to your cluster, right? So far, so good. And in your cluster, you need some kind of API gateway. That gateway will accept your requests, and then depending on what those requests are and what they do, it will scale up, scale down. Basically, this one will create your serverless loads when needed. And then we have your application, which is what I'm going to show you right now. So let me show you how that looks in practice. First of all, those of you pretend that you're all familiar with Kubernetes. That will make my life easier. No. Knative, okay, here we go. So this is my simple definition of my application, right? Ignore that this is a template and all those things. What really matters here is that I'm defining something called Knative. Here it is. And I define some name, whatever that name is, and a few other specifications. And what matters really is that I'm saying, run this image, this container image, from this repository, this tag, run it inside of my server, and you take care of everything, right? Take care of scaling up, scaling down, take care of forwarding requests, make sure that everything works. All I need really to tell you that I want to run Knative, and this is my image, and maybe a few more arguments like a name and things like that. So that being said, let me show you. What do I have in my cluster? Right now, I have, by the way, if you're not familiar with Kubernetes, pod, think of pod as your application. Pod is a container or a collection of containers. So right now, you can see that I'm running nothing, right? I don't have any instance of my application, not a single replica of my application running in my cluster. So what I'm going to do is that I'm going to send a bunch of requests to my nothing, right? So I'm just executing Siege. Siege is a tiny tool that allows you to send a lot of concurrent requests. So I'm going to send, where is it? I'm going to keep sending for 20 seconds, 300 parallel requests all the time. So 300 requests continuously over 20 seconds, and let's see what happens, considering that I have no application running. Oh, I forgot the slide. Before that, now that I saw that my application is not running, and soon I will start bombing it. The reason why it's not running, even though I installed it, even though I deployed my application like 15 minutes ago or something like that, the reason why it's not running is because it's been 15 minutes or half an hour since I deployed it. And during that period of time, I had my laptop closed, I was not sending any requests to my application. So what happened really during that period of time is that Knative decided that nobody's using my application, so therefore it should kill it, right? So there is nothing running simply because nobody's using it. So let's change that. Let's use the application, 20 seconds. Need to wait in silence for 20 seconds, and I will be sending 300 requests. What's happening there? Okay, okay, okay. This is, let's try again. I know what's happening. Okay, I know. What's happening? ADDR. There you go. Let's try again. Okay. It's running now for, ignore the errors. Nobody's perfect. It's running for 20 seconds. It's going to send 300 concurrent requests over and over and over and over again. And there you go. I sent like 8,000 something, almost 9,000, 8,000 requests. And what you can see here right now is that my my application is running again, right? Let me show that easier here. My application was created. Now, if I kept running my request for a while longer than 20 seconds, what would happen is that it would start creating more replicas, right? More and more replicas. By default, it is configured to create a replica for every 100 requests, concurrent requests that are running for, I don't know, half a minute, something like that. I'm not sure about the exact parameters. But the point is that my application started, it will start increasing in size if I continue increasing the number of requests, and it will go eventually down after, I believe, 8 minutes of inactivity or something like that, maybe less, I'm not sure. Anyway, so what I have with this is that I have my application, it is running only when somebody's using it, and it's not running when nobody's using it. And you need to trust me that my cluster is behaving the same. Cluster is also having the minimum number of nodes when I'm not using it, and then it increases when I do. Okay, so that's cool. That's cool so far. So what happened right now is that Knative discovered, oh, okay, somebody wants to send a request to my application. Brilliant. Let me start creating replicas of that application, and so that I can handle a request, so that nobody is left out. Application is relatively fast. It takes like 10 seconds to boot, to create it from scratch. It takes like a few milliseconds to initiate it when needed. Okay, now let's see what do we have here now. It's still running. I don't want to bore you to wait now for, I'm supposed to show you how after 6-7 minutes it will disappear. You will need to trust me on that for now. But let's see how we can combine that with continuous integration, continuous delivery, continuous deployment, whatever you want to call it. We're going to create a pull request, right? I'm not doing anything that you're not doing already. And what we're going to do is that we're going to make a change and push it to that newly created branch. And I'm going to create a pull request. Those are all the things that you're doing yourself already, so nothing new here. And we're going to see what happens when I create a pull request. You can see here that there is a pull request. Some things are happening soon. These are you cannot see that, but you're not complaining. Here are some of the rules. You know, you need to approve it, you need to review it, and all those things that I'm not showing you today because it's not the subject. But my pull request is being processed now by the system, and something will happen in a minute or two. By the time that's happening, let me double check whether my pods are running. They're still running. They did not die yet. Okay. So let's take a look at the pull request activities. So right now what is happening is that, in this case, Jenkins X is processing my pull request. And at one moment it will deploy it, and my application is configured to be serverless, so it will deploy it in a serverless fashion, and it will be running only when needed, and it will not run when not. So now we have 1 minute approximately until this is finished. You can ask me questions for 1 minute. No? Okay, you can watch me in silence. That's okay as well.
How fast does it respond to new requests? Is there any latency creating new nodes?
New nodes or new replicas of application. Latency is in the, so creating a container is almost instant, right? Now the latency the only latency that matters is how much time your application needs to boot up, right? Which is completely independent of containers and this and that. So if your application is fast, and so basically, let's say boot up of your application plus 1 millisecond. Whatever that application is. Now you can, what you can do is configure it further. You can say, okay, my application is a monster big application. It takes a lot of time to boot up, so I'm going to always keep one replica of my application, but I'm going to use Knative to scale up when I need it and scale down when I don't. But instead of scaling to 0 replicas, you can scale to 1, right? But normally, when you go down to 0, you use it only for the things that have infrequent load, right? So if your application is not used by anybody for an hour, I bet that somebody will not mind if they wait for a second between the request and something like that, right? Now, depends on your application, really. Yes. Yes and no. That depends, again, on the architecture of your applications, right? It's like, for example, that would be a good example for Node.js, right, which is a single thread anyways. In this case, I'm running Go-based application, and Go can easily handle hundreds of requests. So in my case, I would configure it, okay, scale up for every 100 concurrent requests. Or it can be 1. It really depends on the type of the application, right? And that's one of the things that, now that flexibility is a bit scary, might be scary because you're in control, right? You need to define how many replicas your application, how many concurrent requests your application should be scaling. Well, for example, if you use Lambda, then you're not in a control, and then you have a replica for each of the requests, which is good and bad, depending on the architecture, really, of the application. Does that answer your question? More or less? Oh, it's still running. Okay. Soon. Okay. Anyways, so what happened while I was answering the question is my pull request was processed by a pipeline. You know, I ran automated tests, I built my application, I stored it in a registry, I did all those things, and I have a message here saying that my pull request is available, and you can click here and review it. Now, this is a complicated application, a complex one. It's hello world. Anyways, the point is that I have my application now ready for somebody to review it. It is serverless, meaning that if I don't do like 8 minutes, I think, after this request, it will be shut down, so it will not be really running beyond anything. So if tomorrow or day after tomorrow, somebody from my team wants to review this application, it will be recreated again, and then it will be shut down after that again. Okay, so my pull request was deployed and all those things, cool. What did I want to do next? I forgot my notes. Okay, so I'm going to merge it. I'm going to confirm the merge. Imagine that I reviewed it and all those things. And it will be deployed to production, to staging soon. It's still running. And yeah, that's about it. Now we just need to wait another 2 minutes. And it will be running in production with the changes saying instead of hello world to hello Knative or whatever I put there as a message. Still there. Any questions? Huh?
Suppose that there are like several developers working on there. They're pushing their pull requests or pulling their pull requests.
Yes?
So they have their instance of their replicas. So each of the developers can have their.
Yes, so.
Of the people which are actually using the request, they make their own replicas. So their own.
Yes. So basically, each pull request, imagine that each pull request has its own, what we normally call environment, right? So if you have 7 pull requests open.
I'm just imagining scaling and actually pricing of that.
But that's the thing, there is no real price. Because if I have 5 or 5,000 pull requests, I have 5 or 5,000 environments, but none of them is using considerable CPU and memory when you're not reviewing those pull requests, right? So one thing is being deployed, the other thing is being running, right? So they're all deployed in their separate environment.
That approach would actually solve some of the problems I had in previous companies, because what we had actually was that we were constantly exhausting the space, memory, and everything, trying to deploy us multiple instances of application.
And usually in those cases, I don't know whether that's usually people end up having 3 staging environments and say, now you coordinate. Open 57 Jira tickets so that you get it deployed here. Something like that. I'm not saying your case, but that's.
Yeah, it was a problem. It was manageable in some automated manner, but I assume this is not good.
Yeah, so now what you can do is you can choose. Like, for example, in my case, I run all the pull request-based environments as serverless. And then the real deal, like production or staging environment, that is sometimes serverless, sometimes not. And whether it's serverless or not, it really depends on going back to the previous question of the boot time of the application, and depends on the load. If I have a steady load, the steady traffic of my application, then I don't really need it to be serverless. I can easily scale it up and down with the horizontal pod autoscaler or something like that. So those are 2 separate things, kind of like, will it be serverless for your pull requests, and will it be serverless for production, let's say, or whatever the environment is. Often both yes, sometimes the answer is no. Okay, new release is being deployed right now. Okay, that was my very quick. Any other questions? Yes, please. Okay. Any other questions? Sorry, that was not a question. That was a comment. Okay. Okay. Brilliant. It wasn't used in a while. So kind of it just has a mind of its own. Any other question or statement? This is cool.
How do you connect, how do you make your architecture so that it's, I don't know, you're distributed logs and the databases? How is this?
So logs today are always shipped somewhere, right? So we're not logging anymore on servers and all those things. That's in distributed systems is unacceptable. So logs are going somewhere, and it doesn't really matter whether it's deployment or stateful set or Knative or something like that. It really does not matter how you deploy something from the perspective of logs. Now, for the databases, that's trickier. It really depends on first on the model that you're using. Are you using a shared database like we were doing in the past, where multiple applications are connecting to the same database? Or are you dedicating one database per application, right? Most of us are now moving towards the latter model of this is an application, it has its own database. And now, if you're talking about production, then most likely you're not going to scale your database to 0 because there are very few databases that can handle that well. So you would have your database running and your application would be scaling from 0 to something to 0 and anything in between. Or you're using a service, which is probably where we are going right now. I don't care about the database, it's a service, and then you don't really care. Now, that being said, I don't scale databases to 0 replicas in production, but I do scale them to 0 replicas in every other environment, like staging, integration, preview, and so on and so forth, because the latency of getting up the database is considerable, but it's not big enough for me not to be able to save resources at the expense of waiting maybe, what does it take to lift the database in those environments, like 5 seconds, something like that. Anybody else?
How does Knative handle metrics?
Metrics, it exposes them through the standard API, in Kubernetes world, metrics equals Prometheus. And Knative itself has a /metrics endpoint, which is automatically hooked into Prometheus. So Prometheus automatically detects it and gets all the metrics about everything.
Because having a metrics endpoint at my application doesn't make sense in this case. So.
No, there are different, those are different types of metrics. So you need the endpoint of your application, and you need endpoint of Knative itself. Knative will give you statistics about what Knative is doing, and your application needs endpoint, sorry, I'm gonna get back to that. Might need endpoint to get application-specific metrics, right? The latency of the specific function in application. Only your application can give that. Now, that's a bit of a challenge with Prometheus, because Prometheus is a pool-based system, right? And you're probably, in case of Knative, for your application, gonna use, if you need application-specific metrics, which is debatable, you're gonna use push gateway. I don't know if you use push gateway. So Prometheus has a component called push gateway. So for cases that there are many, when Prometheus cannot reliably pull metrics from something, then that something can push it to a push gateway, and then it gets it from the push gateway. So push gateway is kind of aggregator for metrics of applications that do not necessarily live long enough for those metrics to be pulled. But then that's not only with Knative. A good example, again, would be CI/CD. So if you have Jenkins, let's say, or anything, you have builds, and builds last anything between a microsecond and an hour, right? And you don't have a guarantee of how long they last, and you need to use push gateway in that case as well. Anybody else? No? Go use Kubernetes first. That's the summary. Okay, so I work a lot with open source projects. Please, you do as well. If you do, please make pull requests to the projects. Don't be a jerk just to use it, not to contribute. This is my blog, podcast, books. I don't have anything else. That's it. Oh. Wait. I have one more thing. I just got it yesterday, literally, so I brought it with me. If anybody wants a book, who asked the questions? You asked the most questions. There you go. There you go. That's it. Go home. No, no. Don't go home. Go to the next talk.
Stay here.
Or stay here. I don't know. What's the next talk? Are you the next talk? You're the next talk. Okay.
The next
Don't talk about Kubernetes. They don't like it.